Hi everyone, and welcome back to the Andy Summers Telecaster project. And in this video we're going to deal with the CAD for the Telecaster body. The neck is pretty much done. I've done a fret job on that. I can put a link in below hopefully, which will take you to the double neck Stratocaster project, which has a run through of how to do the fret leveling, also neck straightening as well if it needs it. Doesn't generally tend to need very much on a CNC neck, but yeah, how to level your frets and get them all polished up so the neck's actually usable and then doesn't cut your fingers to shreds either on the ends. So yeah, link in the description below to that. So anyway, what are we doing here? Well, we need to get the Telecaster body modelled, and you can see that the finished result there, but that's obviously some way down the road, so I'll show you how I get to this. And the way I start these is there's a number of PDF plans for various guitars out there. I think there's a German site actually that has an absolute bucket load of different guitar types. You know, Les Pauls, Telecasters, Strats, Jags, Jazzmasters, you know, arch tops, you name it. Bass guitars of various descriptions on there. So yeah, there's a but this particular one I think it's done by one of the guys over in the TDPRI forums, and I'll link them below because it's an absolutely brilliant resource for anything to do with Telecasters. And one of the guys on there has been working on this, or worked on the Telecaster plans for some time. The last revision to these plans were done in 2010, and I think that's pretty much as accurate as you're going to get for a standard SS, so it's a single core pickup Telecaster, solid bodied one. There is a plan out there for the thin line semi-hollow Telecaster as well, if you wanted to have a go at one of those maybe one day. But anyway, yeah, so here's the plan. It's absolutely covered in detail, and it's absolutely fantastic because there is just pretty much no measurement missing off of this. And crucially, it matches the neck plan as well, which I use to make the neck, which means that this neck pocket here is going to match up with the neck, hopefully perfectly, with a little bit of tolerance for machining built in. But yeah, anyway, so all this detail on here is fantastic, but obviously for CAD work there's just way too much on here, and certainly with Fusion 360, something to bear in mind when you're converting plans into CAD drawings is that, you know, keep it simple. So pare down to the absolute minimum information you need to import, and then turn that into a model. And the reason for that is if you leave a load of detail on here, it just causes major aggravation when you're trying to work on it in Fusion 360. Plus the more of the vector lines that you've got on these drawings that you transfer across, the slower Fusion 360 will run. And I've bought Fusion 360 to its knees on my machine, which is a quad-core 8-thread Intel running at 4.4 gigahertz. So you know, it's a fast machine, and we managed to pretty much kill it with one import I tried. Anyway, so how to tidy this up? Well, unless you've got PDF editor, what you're going to need to do is go through another package, and what I use is a package called Cut 2D. Now what that does is it allows me to import PDF, and then I can highlight loads of the vector information and delete it. So you can see here that what I've done is deleted everything apart from the bits that we need to make the body in CAD, and then I've exported that in a Dxf format because for some reason I can't get PDFs to load natively as a vector diagram essentially into Fusion 360. Probably something to do with licensing between packages, but I can import PDF into Cut 2D and then export into Dxf. and then you can import your Dxf into Fusion 360, and you will get essentially this. The Dxf will import directly into a new model as a sketch, which is fantastic, and then it's just a case of editing the sketch to get going. Now the first thing we need to do, and this is most important, is for some reason Dxfs when I import them like this are exactly 10 times the size that they should be, and I've checked this with you can check this with using the inspect tool. If I select those, I know that that is supposed to be 1 inch or 25.4 millimeters apart, and we can see that it's 254 millimeters apart, so we know it's 10 times the size that it needs to be. So what do we do about that? Well, we need to rescale it. So we need to scale, and the way we do that is we select everything just by lassoing it, and you saw there, hopefully, possibly, the swirly cursor whilst it selected everything, and this is one of the reasons we'll do some of the operations we'll do in a minute to clean this diagram up. So we need to scale this, so if we go to modify and scale, we select 0.1, click OK, and that's rescaled our diagram. Now we also need to move it a bit here as well, but it's probably good practice that we shift this so that this point here matches the origin here, especially with the halfway line. It just makes it easier to work with. So the way we'll do that is we'll select the whole model, wait for the swirly cursor to stop again, and this time we'll right click, select move, and operations like this are a pain until we get rid of a lot of this geometry. So the movement type we're going to use is point to point. So the way we're going to do this is we're going to use a point to point move, but before that we're going to need the point that we want to move actually in the geometry. So what we're going to do is I'm going to just put a center circle there, just so I've got a point of geometry there. Select everything, and we're going to right click, select move. I'm going to select the point to point move. I'm going to select the geometry we just created, and then we're going to select the origin, and that's just shifted everything over. Now you can see here that we've got absolutely bucket loads of points on here and loads of separate geometry, and this is what's slowing up Fusion 360. So we need to get rid of it and start replacing it. So the way we're going to do that is I'm going to click OK to finish that operation, and you see all these segmented lines here. We're going to get rid of these in this nice curvy line here by replacing it essentially with a spline. So if we get a spline, we'll go to that point there, and what we'll do is where we've got points in segments on the original geometry, we'll click to place a new point in our spline, and we'll put more points where there's sharper curves. And what what Fusion 360 does is it smooths out this curve based on the previous points that you've selected. And we'll just run around, and I'm going to do this pretty quickly so we can use less points in this area. We'll start to put more in around here, and it will do the best it can essentially to make a nice smooth set of lines. Yeah, we're going to need more here. And we probably want that one there, that's it. So we'll finish the line by clicking the tick there, and that finishes that spline basically. And then what we can do is we can go in, and this is a bit of a fiddle, click, and this takes a little while, and delete all the old geometry. You can see we've got a segment in there we don't need anymore, and basically just work your way around and delete all the old imported geometry, so all we are left with is the nice smooth spline line, rather than kind of this faceted sets of curves here. So anyway, that's what we do on that side. We then do the same from here down to this straight line actually, which is on where the instrument jack is. So we do one spline down to this area, another spline along the bottom, round to the neck pocket, round all this geometry. All these curves where we've got a semicircle, so for this pocket here, which is where all your pots are going to be, we can, the way I do that is I draw a line between the end points of the straight line, so where that finishes, like that, and it's perpendicular, so we know it's the right place. And then if we just highlight all the rest of it and delete all the old curves, then we can use an arc. If we use a 3-point arc, so we click there, and that essentially snaps, look, a semicircle on the end, and then we can go and take away that line, and we know that we've got a nice semicircle made up of a single piece of geometry that Fusion 360 uses. And similarly, if you look at these radiuses here, these will be tangent arcs essentially from these straight lines on this side. So if we just take all this old curved geometry away, like so, and then we use the 3-point arc again, and if we click on that line there, for example, and then that line there, point there, and it will snap to a tangent arc, you see, between the two. And there we've replaced a nice replaced all that segmented faceted geometry with a nice smooth spline. Similarly, the other bits that we need to do on here is we need to look at the circles here. So, and the way I do these is I check the original diagram. If I just bring that up, and these holes here, you see the cross section DD there. So if we look at section DD, we can see that the holes are 1/8 of an inch. So we can just do, and I'll do one here. So if we click that center point, and then if I type in 0.125 and then inches, and hit return, it automatically converts it to millimeters, which is fantastic. And then we can again delete all the old faceted geometry. Okay, so basically we need to run through the whole diagram. So essentially you're almost drawing the whole thing again, but you're obviously doing it a lot quicker because you're just replacing existing geometry. We don't need these hashed lines because they can all be deleted. They're just the drill showing where the holes are drilled between the pockets. And just to show you what these pockets do, so obviously we've got the neck pocket here and the holes that are going to bolt the neck on. We've got the neck pickup. Now, in mine I'm going to replace this with a humbucker route, which will kind of be an oblong there with a couple of lobes on it. We've got this route here, which is essentially just a wiring cavity, and it's to get the wire from there to there and there to there. Then we've got the bridge pickup, which has its own kind of plate, if you've ever seen one of those, but we'll actually be screwing a pickup directly into the wood on this one, because that's how Andy Summers' guitar was. And then obviously we've got our through holes for the strings, and we've got our 4 holes for the bridge itself, and then the control cavity. It's a very simple guitar, the Telecaster, which is good news. So once we've finished that, what we can then do is we can extrude. So okay, so here we are, we've got our cleaned up sketch pretty much, and we need to make the body out of it. So the way we're going to do that is we are going to do a press pull. I'm just going to select one to start with, and then I'll start selecting all the other bits of geometry that we're going to press pull and then extrude. And what we're going to do here is we're going to extrude down, if you like, from this, so minus 1.75 inches. If I just check the plans again just to make sure, and indeed it's 1.75 inches thick, that's right, on a Telecaster. And we just need to select some of this other geometry. I've had difficulty sometimes when selecting lassoing geometry for extrude, so I tend to want to do it manually, which is a bit of a pain, but there we go. So the reason I'm leaving these holes here blank, not selecting them, and also the holes here, is because those are going to be drilled right through the body anyway, so there's no point in extruding those. So okay, if we type 0.175 again and put the quote mark on the end for inches, and make sure it's creating a new body rather than attaching to the one I created previously, and then we click OK, and there we essentially have our Telecaster body minus all the pockets. Now if we switch the sketch on again, we can start to extrude these down. So best way to do this is go back to the diagram. We can see that the control cavity is 1.5 inches deep, so we just press pull that shape, minus 1.5 inches, and he says no, come on, there we no, it's still not doing it. There we go, and we just make sure it's on cut as well. Let's just do another one. So the bridge pickup cavity is, let's see, we got 0.85, yep, 0.85 inches. So we go back to the model, select those two, press pull, and minus 0.85. And for some reason when I hit my key it jogs the mouse, and there we go, inches again, and over here just make sure it's uncut, and then we just basically work our way around through all these pockets. Now whilst I got the geometry in for the ferrules, they're on the other side, and what I'll probably do is just drill those out with my drill press, but we will drill the holes through on the CNC machine, so the through holes. Similarly, we'll just drill the hole here for the screw pilot for the bridge fixing screws, but we won't do these. This is the actual screw head, if you like, so just do the pilot holes there, and that's going to be pretty much it. So as we work our way through all of this, now I've given this the appearance of wood, and here's one that I did earlier. So we have now essentially got our body, standard body. Now I had considered getting the CNC machine actually to do the binding rebate that runs all the way around this edge here and around this edge on the top here, but I've decided not to do that. I'll do that on the routing table, mainly because to cut this body out I'm going to have to do my cam in 2 sections, so I'm going to have to essentially decide on a point, and it's probably going to be a line somewhere along here, machine all of these pockets and the cutout for the top half, if you like, or top 2/3. Then I'm going to have to move my blank over on the CNC machine using some indexing points, and then do this control cavity and then cut out the bottom part. Now that I should be able to do it accurately enough so I get no step, if you like, at the point, you know, the join essentially between the 2 halves, but I'm not going to risk that on the binding channel, which I think is probably easier if I just run that round the router table, and plus I've got to do it on both sides anyway, and to make this a 2-sided model piece of CNC adds even more complication, because then you're looking at you know, not only doing a flip, which you need indexing posts for, but you also need the indexing post to do the 2 operations on the other side as well. So a lot of palaver when it's easier just to run it round the router. So anyway, there we are. That's our CAD, and there's our body ready for cam. But because this video's gone on quite long enough, I'll leave this here, and we'll come back in the next video and I'll show you how we're going to do the cam for this. So thanks for watching as ever, and I'll see you in the next video.